Welcome back. We are pushing on with the built-in functions, only a couple left. And this video contains 3 that are very short, simple to talk about, and they're all kind of mathy. They have to do with numbers. And the first of the 3 we'll talk about is called abs, stands for absolute value. If you're not familiar with absolute value, I'm going to do a terrible job explaining it. I don't remember the official mathematical definition, but the absolute value of a positive number is itself. The absolute value of a negative number is the positive number. So it's a way of just taking the numeric value without the negative sign. So -5 turns into 5. 5 stays as 5. So we just pass in a number. ABS, abs, -5 gives us 5. ABS 5 gives us 5. Quick example, do abs of -23, gives us 23. It also does work with floats. So I could do absolute value of 3.44444, and it gives me 3.44444. And if I do the negative, it gives me the exact same result. And that's kind of it. It only works with numbers and with integers and floats. So if I tried to do a string, it's not going to try and convert it to an int or a float first. It just immediately tries it as is. It does not like that. So, if we're getting user input and it's a string, we could do float of 20 or something like that. And then that will then convert it to a float from a string and then do absolute value. As a side note, there is another method called fabs, which you have to import with math. Import math. And we could run math.fabs, which I think it just stands for float absolute value. And it will do the exact same thing, but it treats everything as a float first. So if you pass in an int, it converts it to a float, and so we get 4.0 instead of 4. Next up, we have sum. So also mathy. All that it does is it will take an iterable, a list, a tuple, whatever, and it will take an optional start, and it will just add all the elements together. So the sum of everything in that iterable plus the start. So I'll show you what the start means. But what's important, it goes from left to right. So it starts at the left side and it keeps adding until it gets to the right side. Start by default is 0. So let me show you what I mean. Let's just try adding a simple list. We could do sum of 1, 2, 3, right? So that should give us 6. It goes from left to right. So the optional start that we can provide has to be a number. If we did something like 10, it will start at 10 and then add all of these numbers to 10. So it's a starting point, and this should give us 16, as you can see. Or if we did -6, we'd get 0. So it starts there, adds 1, adds 2, adds 3. Other than that, let's see. We can do, tuples if we wanted to. We can do floats in there. So let's do 2 and 3.7. And it returns a float, even though one of them was an int. We could also do a set containing numbers like that. One somewhat interesting thing, if we try and sum strings, like a list of strings, like hi and there, if I just do it on its own, I need the quote, we're going to get an error. We're going to get an error no matter what. But the first one is it's going to try and start at 0, the integer 0, and add it to a string, and it gives us an error, unsupported type plus int and string. It doesn't know what to do between an int and a string. So if you actually provide your own start, and instead I tell it to start with, LOL, you would think it could just add LOL plus hi plus there and give LOL hi there as one string. But instead, it gives us this custom error here that's in the source code. Sum can't sum strings. Use join sequence instead. We've already seen how to do that. Empty string.join. So we could do the exact same thing, where we just take this, empty string.join, pass in the list, and we get hi there. But I just think it's interesting that there's actually a note, a custom thing in the source that tells you not to use sum. And on the documentation, you can see they actually have a note here too. For some use cases, there are good alternatives to sum. The preferred fast way to concat a sequence of strings is by calling empty string.join. To add floating point values with extended precision, so for a more precise way, there's in the math module, a method called fsum, just like we saw with fabs f, absolute value, float, absolute value. Anyway, that's all there is to sum. Finally, we have round. So round will take a number and it will return a rounded version, and we specify the number of digits, how precise we want the round to be, how many decimal points it should round to. And by default, it will return the nearest integer if we don't specify, the number of digits. So for example, round 10.2, it just assumes to round to the nearest integer. So that doesn't mean it will floor it like integer division or something. It will round it appropriately. But if we specify 2 digits, then it will give us 1.21 in this example. So we can do round of 3.5, 1, 2, 3, 4, and let's round. If we don't specify anything, it gives us 4. It rounds up, in this case, to the nearest integer. But if I did to 3 digits, I get 3.512 to this third decimal place. What else? That's pretty much it with round. If we manually specified none, it will also round to an integer. So by default, if you don't specify or you actually pass in the value none, then it will round to the nearest integer. And that's kind of it. I guess you should be aware of the fact that, floats are only precise so far. So if we had a massive float like 9999999 and it kept going, that's got to be past the largest float we can store. And we try and round it to, 15 decimal points. It just rounds up to 10. So at some point the precision slips. Just worth knowing about. But if you need something this precise, you're probably doing something crazy. I don't even know what you would need to be that precise, honestly. But if you were, then you would also probably know a way around it, or you have a supercomputer to help you or something. Okay, so those are 3 built-in functions I just lumped them together as mathy. So we had absolute value, abs, sum, and then round. We have one more in the next video, and then we've covered pretty much all of the built-in functions.